This is thermal physics, build up your understanding, question number 13 from the book Pathfinder. Let us see how is the question, what's the question and how should we solve it. So question is, there's a mixture of equal amount of water and ice. It is placed at 0 degree and it is left in a room. The entire ice melts in 160 minutes. Room temperature is given, that's 25. The specific heat of water is 4.2 and latent heat of ice is 320 given. Now, if it is further left in the room undisturbed, then how long would it take to increase its temperature from 22 to 23? So that's the question, right? So here nothing is given whether we can apply Newton's law of cooling or we have to apply Stephen's law. So here what we are going to do now, since, see what happens. First, we are assuming the mass of the water as m, mass of the ice as also m. It's given, both have equal amounts. Now, if you see T minus TSS, for first condition is 25. For second condition, it is even lesser. So T is temperature of the body, which is ice water mixture, and temperature of the surrounding is 25. So T minus TS is 25. When you are taking the difference, it doesn't matter whether you're taking in degree or Kelvin, but TS is in Kelvin, right? So TS is 298, this is 25, it is less than 10%. So if it is less than 10%, binomial approximation is valid. So Newton's law of cooling is actually based on binomial approximation of Stephen's law, right? So we can see that T minus TS is very, very small as compared to TS, right? So don't compare this, right? T minus TS with the TS, then you might think that, okay, it is equal. But here TS is in Kelvin, but T minus TS, you take any scale, difference of temperature will always be same. So in this case, actually, we can apply Newton's law of cooling, right? So that is why this question is given. Now, Newton's law of cooling is dq by dt is equal to k times T minus Ts. This is rate of cooling. Sorry, this is rate of heat loss. And this K, is T temperature of the body and Ts is temperature of the surrounding, right? So I'm going to apply this for first condition now. In first condition, what happens? Ice melts in this time. So when ice will melt, temperature of the mixture will not increase because it is ice water mixture, and total heat which will be needed is, or the heat which we will get as ml, right? So that is what I have done. So first case is heat released in melting will be Q equal to ml, and that heat will be ml is equal to K times theta r minus theta naught, right? Newton's law of cooling. Theta r is the temperature of room, theta naught is the temperature of mixture, which remains 0, so no approximation here, into delta T naught. Delta T naught is how much given? 160, right? So I'm solving in the terms of symbols. So here, this equation, fine. So the equation is clean equation. Now, after that, when temperature changes from theta 1 to theta 2. So let us see what's the range of theta 1 and theta 2, 22 and 23, right? Again, very close. So still we can apply Newton's law of cooling. So when we apply Newton's law of cooling, we can apply the average Newton's law of cooling here. K times, again, theta S here is, this is theta S, right? So theta R, room temperature, and temperature of the body is changing from theta 1 to theta 2, right? So since theta 1 and theta 2 are very close, here in this T is what? T is temperature of the body. But temperature of the body is changing from theta 1 to theta 2. So we take average of this, theta 1 plus theta 2 by 2. And let us say it takes T1 time, right? So this will be equal to, this is the total heat lost. This will be equal to what? Total mass now, I have to take 2m because m was mass of ice, but water is also there. So now from 22 to 23, it is 2m amount of water. So m, s and delta t is theta 2 minus theta 1, right? So this is theta 2 and this is theta 1, which is 1 degree. Okay. So that's it now. This is second equation. We can just divide these two. If we divide these two, then K will cancel. And if you multiply this by here, you get this. And T1, the time you get as 4 times theta r minus theta naught, room temperature. And theta naught was 0. Theta 2 minus theta 1. This is the second condition. The specific heat, delta T naught is given. And these are the same symbol, right? So that's it. That was my analysis. If you have liked this analysis, please hit a like button to this video. And please subscribe to this channel also. Thank you very much. All the best.